Our first session this morning is led by Dr. John O'Shea, who is a professor in the Department of Anthropology and curator of Great Lakes in the Museum of Anthropological Archaeology in UMA. And the title this morning is Bringing Submerged Sites to the Surface, Theoretical and Methodological Challenges of Integrating Terrestrial and Underwater Records. John.
Thanks, Rob. And, you know, I offer my thanks to all of you who were able to actually wander in here this morning. I mean, I know it was kind of a challenge for me, so it must have been a challenge for you as well. Seashores are evocative and yet familiar places. And they always seem the same. You walk on the beach, you feel the sand between your toes, you feel that gentle onshore breeze. The waves are lapping, creating ripple marks in the sand. And it seems really permanent. It looks the same way when you see it as a child as when you see it as an adult. But this permanence is illusory. We know that sea levels have changed radically in geological time spans and in human time spans. They don't stay the same. And as a result, we're left with this kind of spurious present, that where the sea is now, it wasn't before, and it won't be again. And so, how do we deal with this as archaeologists? If the very shore, which we know is one of the most productive places for people to live, is varying all over the map. And the one thing that's fortunate about this is that even as they change, landforms are similar. So you still have bays, you still have sandbars, you still have rocky heads. And it turns out that we can identify these and have identified them on land. So for example, this is a topographic map from northern Michigan. And if you look at it, we can add in the shoreline that dates to 6,500 years ago. And it has all the features that you'd expect of a modern seashore. We can also add in the wave-cut bluff there, which is equivalent to Lake Algonquin, which is 13,000 years ago. So we can recognize these landforms. And terrestrial archaeologists have been aware of this. I mean, the whole chronology of the European Paleolithic, the thing that we had to memorize as students, is basically based on river terraces on the Somme and the Thames that are reflecting global changes in sea level over geological time spans. So we've known about this, but what is missing? There's another half of this equation. What about things that are below the modern sea level? And it's not a trivial problem. Most North Americanists are familiar with the idea of Beringia. The students think of a land bridge that you tiptoe across, but in fact, it's a massive extension of a continent. In Northwest Europe, likewise, everything that's in light blue is dry land. Southern Africa, the hearth of humanity, same problem. In Southeast Asia, again, the same problem. Now you might ask, why in a 100th anniversary of the Museum of Anthropological Archaeology am I talking about global sea level? Well, it turns out that a Michigan geologist named George Stanley was one of the first to recognize that there were preserved low water stages in the Great Lakes. And he was assisted in this activity by the first curator of Great Lakes archaeology, Emerson Greenman, who immediately recognized the archaeological potential of identifying these submerged landscapes. So what is the terrestrial approach to submerged sites? Well, there have been some practical approaches. One is you look at caves in areas where you have a very narrow and steep continental shelf. And the idea there is that the environment hasn't changed a whole lot, even as sea level goes up and down. But for the great majority of archaeologists, you basically either speculate wildly about what might be out there, or you simply ignore it, treat it as though it doesn't exist, under the assumption that even if there was occupation there, it would be destroyed. And the reality is that this isn't true. That submerged landforms are present and can be identified. They can be studied systematically. They have environmental and cultural contexts that can be reconstructed. In fact, you have to reconstruct them to do anthropological archaeology on these landforms. And finally, they contain data that doesn't exist anywhere else. So unless you can account for these submerged landscapes, you don't have a complete archaeological record. So that's the motivation for the talks today. We've been able to invite four young researchers who are in the forefront of this work in different parts of the globe. And I've asked each of them to think about what is it that we're missing and how might we go about using or recovering this kind of information that is sitting out there under the seas. So the first of our presenters today is Dr. Helen Farr, who comes to us from the University of Southampton. She's an associate professor there. She specializes in underwater archaeology. She's a commercial diver, an avid sailor, and a very avid proponent of the preservation of underwater cultural heritage. So with that, I'll introduce Helen.
Thank you very much, John. And thank you for the invitation to be here. It's a real honor to be here celebrating the centennial anniversary. So this morning, we're talking about submerged paleo landscapes, the challenges, developments, and the future. And I thought I'd start with acknowledging that a vast amount of our planet is covered in water, 71%, and rising. I want to start with these beautiful images here. It's an art installation by Anthony Gormley called Another Place. It's on Crosby Beach, over in Liverpool in the UK. And it includes 100 cast iron sculptures of himself installed along 3 kilometers of foreshore and up to 1 kilometer offshore. These sculptures really make me think about submergence on the human scale. Twice a day, many of these sculptures are engulfed by the tide. They weather storm surges and wave action. They are buried and re-excavated. By changes in sediment, deposition, scour, and movement, they're eroded and felled. They make us think about human activity in the coastal zone, permanence, transience, and rising sea levels. And it's not surprising that this artwork speaks to me as an archaeologist. Gormley actually studied archaeology and anthropology at Cambridge University in the 1960s, my alma mater. In fact, where I was mentored and educated by a multitude of Michigan alum. And so, from the human scale of tides and weather and flooding, to the broad scale, climate change, landscape change, and human response to it over the long durée. Multiple cycles of marine transgressions and regressions shaping the coastline in many regions. Hold on, get it moving. There you go. Is it moving? Yeah. Shaping the coastline in many regions around the world. The continental shelf has repeatedly been exposed and inundated throughout human history, physically changing the distribution of landmass resources and the marine environment, having a profound effect on our ancestors' lives. And even through these repeated transgressions and regressions, due to geomorphology and taphonomic processes, depositional sequences can and do survive, with artifacts that can be retrieved from both in situ and derived contexts. So by expanding our archaeological research offshore, by investigating these areas once dry land and now flooded by rising sea levels, we can integrate our data sets and our narratives of land and sea and gain a better understanding of human history. And it's important to stress here that this does not necessarily always reference coasts and maritime landscapes. The submergence extent of the continental shelves represent an additional 5% of the land area currently exposed across the globe. So in many regions, current coasts and near offshore zones were once just terrestrial landscapes. One of our challenges is how to integrate the onshore and offshore archaeological data, perhaps through acceptance that what we're doing is not necessarily maritime archaeology, but simply archaeology, whether on a flooded shelf or dry land. And we can therefore avoid this distinction. What we're doing is merely just a difference in methodology. So global changes in relative sea level of up to 120 to 130 meters are seen from the last glacial maximum, and they have a profound effect on movement of modern humans and on the archaeology we have. A significant proportion of the prehistoric record has been submerged during the last post-glacial marine transgression and those that preceded it. If we look at the Sahul shelf, that's Australia and New Guinea, and I'm going to be talking about that more today, around 2 million square kilometres of what was once potentially inhabitable land is now submerged. These now submerged landscapes contain a uniquely important resource for improving our understanding of human history and environmental change. Through studying these landscapes, we can address the big questions of global migration, population movement and colonisation. We can address early seafaring, skills and knowledge, better understand the significance of marine resources and coastal adaptations in deep time, so often lost because the sites that we look at on today's coast were actually on land. So the maritime coastal areas in many regions are missing because they're submerged. We can map landscape change in paleo-environment, climate and sea level change. And we can do this at varying resolutions, from the broad, regional and local scales of change, and importantly, human response to it. This gives us a unique set of tools to contribute to some of the big challenges we're faced with today. We've just entered the UN Decade of Ocean Science, and I believe the work already underway by many of our archaeological colleagues show that we have a serious contribution to make. One of the actions of the decades includes high-resolution mapping of the oceans, understanding and mapping submerged sites and landscapes, and what we can learn about human response to climate change in the past ties into the interdisciplinary challenges and the sustainable development goals set today. But more than this, maritime heritage, both tangible and intangible, plays an important role in forming and maintaining community, identity, and well-being, issues addressed by the decade. So where to start? Well, mainly here perhaps, that I'm not just stressing the potential to find preserved landscapes and sites underwater. In 2020, Fleming writes that we have over 3,000 known submerged prehistoric sites, many of these accidental finds. But this work isn't particularly new. This beautiful image dates to 1854 and shows the geologist and antiquarian Count Adolphe von Morlo excavating a submerged prehistoric lake dwelling in Lake Geneva. So not just coastal plains, but lakes as well. I thought it was important to add that bit. Also, please note the very early surface supply dive helmet. I don't really fancy that one. So of course, dive technology has progressed a lot, and we're finding more and more sites. And the great thing about submerged prehistoric sites is the taphonomic conditions. Preservation underwater can be exceptional, with organic materials preserved where they would not have been preserved in terrestrial contexts. Both the artifacts, the material culture, and paleo-environmental record can be superb. This site here is a steeply shelving, highly tectonic zone of southern Italy, raising questions about our expectation of preservational contexts. Here we found Neolithic peats packed full of plant macrofossils. At the top you can see a little acorn in its cupule, for example. But here even more. These plants were preserved in macrofossil form throughout these peats, giving us a really beautiful idea of what that coastal landscape was once like. Now, of course, dry, denuded, and a very different place to be. Okay, so we have challenges. Working underwater in the intertidal zone isn't always that easy. There's questions about bottom time, visibility, and cost. Here you can see what it's like at the top working locally in Southampton. It's like diving in cold tea. We also have issues of scale. Like, how do we do work which is relevant and answer the questions we need with the sort of scales of data? and the gaps in those data sets as well. So there's an issue there. Understanding variability of taphonomic environments, the fact that we've found those beautiful preserved peats eroding in a place where we did not think we would find them suggests that we need to broaden our understanding of where material can be found in the submerged zones. And of course, integration of narratives, I'm going to talk about that in a minute, and accessing industry data can be difficult, and the resolution of that data. So, solutions. Of course, working underwater is a challenge, but we need to focus on the positives from offshore and subsea research. Due to technology, we can now collect immensely high-resolution datasets. Remote operated vehicles and autonomous underwater vehicles and ship-mounted sensors enable targeted data collection and high-resolution imaging of the seabed and the subsurface from shallow coastal waters all the way across the continental shelf and now beyond. In many respects, we can now rapidly survey and model landscape change offshore better than we can onshore. And due to commercial offshore developments, subsea cabling and pipelines, wind farms and oil and gas industry, there's a large extant data set in many areas of the world. What is now needed is to enable data sharing and to strengthen the interdisciplinary links. So I'd like to move on now to present some of my own work. This is the Across project, and it's important to say that the Across acknowledges the Aboriginal and Torres Strait Island peoples as the traditional custodians of the sea and lands on which we undertake our research, and we pay our respects to elders past, present, and emerging. The Across project is an ERC-funded project studying some of the earliest seafaring in global history, tying to big questions of human origins and our changing planet. So doing so is in context of an accurate paleo landscape is very important. We're studying seafaring from Sunda, island Southeast Asia, to Sahul, modern-day Australia and New Guinea, in deep time. And to do this, we need to understand the changing land and seascape and the now submerged paleo landscape of the northern Australian shelf. The approach to this is a combination of multiple forms of ocean and earth science and combined with archaeology and genetics that recognises the importance of Indigenous history and knowledge. And it's really important to say here that as an outsider with the Western scientific understanding of the world, for me, this includes the notion of trying to understand seafaring within a framework of global human migration, but accepts, respects, and acknowledges different ontologies, including many people's belief that they have always been on country. Whilst the chronology and notion of arrival of people in Sahul is debated, the earliest date range on archaeological sites suggests people were in the region by around 50,000 years ago and maybe as early as 65,000 years ago. Different forms of knowledge and different ontologies can be difficult to coalesce, but doing so brings richness to the narratives we can tell, both about early seafaring and coastal activities specifically for this project, but also more generally for ocean and earth science, sustainability, and the human past. We highlight the need for the inclusion of these integrated interdisciplinary approaches to understanding human relationships with the sea and the importance of maritime and underwater cultural heritage, which we know can be and is preserved within these submerged paleo landscapes on the continental shelf. Such paleo landscape research on the submerged shelf talks to multiple identified sustainable development goals in the decade, so we have much work to do and potential to contribute. So to understand this really early and important maritime activity, we need to understand what the landscape was like, what the seascape was like, and we need to take a multidisciplinary approach. So what have we been doing so far? Well, we've been researching changing seascapes to understand both seafaring and life on the coast in deep time, running powerful ocean circulation models, which are essential to global climate models, and understanding climate change through glacial cycles from marine isotope stages 6 to 2. Alongside these ocean and circulation models, we are mapping paleotides with changing sea levels and the changing geomorphology of the paleo coast. That informs us of the changing coastal environment and changing ecozones. but also of available resources and potential lived habitats. But to understand movement and seafaring between Sunda and Sahul in deep time, we need to first understand where the coasts were. And in case you're wondering, this is where the submerged landscape work comes in. A big part of this project involves using offshore industry data and 2D and 3D seismic analysis to understand the changing nature of the now submerged coastal landscape, better understand sea level change, to locate the paleo coast in order to help us interpret changing features and changing environments. I'm going to show you just a few of the data sets we've been working on, concentrating on the Bonaparte Gulf region, but we've been doing new work in the Arafura Sea and the Gulf of Carpentaria as well. In the last few weeks, trying to understand changing paleo seascapes and coastal landscapes is really, really hard. And it's a very dynamic zone, especially when you're looking at the depth of time that I'm interested in, which is marine isotope stage 4, 71 to 59,000 years ago, to coincide with some of those earliest dated archaeological sites. So why start with the Bonaparte Gulf? Well, there's various reasons, but if you're interested in Birdsall's routes into Sahul, this is an important part of the crossing for Timor or Rote Island on the Sunda Shelf into Sahul. It's also one of the areas where there's the first and earliest research into paleo landscapes on the Australian shelf. And this work was conducted by Nick Fleming 40 years ago in 1982 as part of the Sirius expedition. So within this, Nick was working on the submerged quaternary landscape of the Cootamundra Shoals, which you can see up there, 240 kilometres northwest of Darwin. So this was one of the first surveys of submerged quaternary landscape in Australasia to recognise the cultural importance of these offshore landscapes, both for understanding movement into Sahul in deep time, but also the changing coastal environment. So apparently when visiting this site, Rhys Jones said confidently to Nick that if he could remove the water, he would very quickly find him an early site. Well, the available data is somewhat different now from the early 80s. Another reason for choosing this region, and luckily for us, there's a lot of offshore industry here. So we're undertaking an integrated interpretive study of the evolving submerged landscapes of the late Pleistocene on Northern Australian shelf using oil and gas industry 2D and 3D seismic data, together with some core borehole data to determine low stand paleo environments and shoreline positions over the last glacial period, so MIS 1 to 5E, but with a focus on the low stand of MIS 4. Now, these are data sets we've analysed so far in the region, thanks to Geoscience Australia. We have 16 3D data sets, high-resolution 2D data, and hundreds of 2D lines to stitch them together. This is big data. It's a big area. I could drop the British Isles somewhere in that Gulf, pretty much. So it's a really big challenge. The other issue with this industry data, as I'm sure some of you will know who's worked with it, is that we're only really interested in the top few seconds. And this data wasn't collected for us. It wasn't collected for people interested in late Quaternary paleo landscapes or archaeology. So we need to do a lot of seismic processing to make it high enough resolution to be able to actually use it. And here's an example of inverse Q processing that we've done on the data, which has really added to that resolution and means that we can actually use it to ask the questions we want to ask. So we have lots of data, but also not enough. We don't have enough cores, for example. This will be the next challenge. We definitely need more. I know from the Black Sea Map project, which I was a co-I on in recent years, where we collected our own original data rather than using industry data. We did 2,000 kilometers square of geophysic data collection, side scan sonar, sub-bottom, tied in with 100 cores to the tune of £20 million of research funding. This is expensive work, and this scale of shelf is even bigger. So we have to work collaboratively. We have to work with industry if we want to do it on this scale. We do have some industry cores, and we have recently recalibrated the dates to help us provide boundary data to calibrate the seismics and interpret sedimentation rates. It also helps us pin down our sea levels. So here is just an example. Marine isotope stages 1 to 6 are identified within the top 90 meters of events below the seabed. These are high-resolution 2D lines available in Petrel subbasin, which is in the Gulf. So these lines have proved key to understanding geomorphology over the past 125,000 years, as they allow us to identify high stands. Those are the thin, parallel, low-energy environment seismic reflection events you can see here, and low stands, which are the incised, chaotic, and intra-channel on-lapping seismic reflection events. And so we can interpret these, and as such, we can see here MIS1, MIS3, and MIS5 as high stands, and the low stands, MIS2 and 4. And this has enabled extensive 2D and 3D reflection database to be created for the Northwest Australian shelf, centering on the Bonaparte Gulf using publicly available archives. So interpretation of the seismic data is constrained by data stratigraphy in shallow cores with low bounds determined from oil and gas well bores. We can then reference this against the relative sea levels and identify subaqueous or subaerial deposition. So what we have here is the MIS4 mapped sediment locations alongside the 80-meter contour. And if we focus on MIS4, we can see an interpretation of evolving coastal and fluvial emergent landscape. On the shelf edge, we can identify reef, beach, estuarine, and lagoonal fluvial facies associated with the MIS4. The spatial location of this environment is controlled primarily by relative sea levels. Moving south into the Gulf, we can see dramatically changing landscapes. Fluvial systems, major drainages several kilometers across, estuarine and intertidal features. What we're looking for is relative impedance. What we're looking at here, is a relative impedance slice for the Petrel 3D in the Bonaparte Gulf. In the MIS4, we see the diffuse features in the middle there, interpreted as estuarine lagoonal environment. But if you look at MIS2, we see fully emergent landscape. And in the transition between MIS2 to 1, we can see a significant increase in fluvial sedimentation and at least 3 different phases of fluvial activity. And we think that this possibly might be connected with the switching back on of the monsoon system. So where does this lead us? Well, as archaeologists, we're very interested in what this means in terms of the paleo landscape, potential areas for preservation, and understanding the coastal ecology. But quaternary seismic specialists are very wary about this sort of thing. So here's a very basic interpretation. Here we see basically a dominant landform, low stand at around 80 meters with a plus minus 3 meter, which correlates to the paleotidal modeling as well. And we see a broad barrier to the northwest formed by the subaerially exposed Sahul platform, which you can see out on the side there. This is an extensive region of islands, inlets and channels which borders a lagoon to the southeast of around 40,000 kilometers. We're also able to identify karstic landscapes, mud flats, promontories, reefs. Matching these with similar sorts of modern environments we can see today. This is just a first step in understanding the changing nature of the coastal environment. And we can see where sediments are preserved across the Gulf, and through this, a deep understanding the types of archaeological sites that might be preserved in these environments. Future steps could include identifying areas for further coring and for further study. At the moment, that's outside the scope of my project. However, it raises questions about how we could achieve this. Not only has the technology come on a long way in the last 40 years since the Cootamundra project, but so has the awareness of the need to take a community-led approach to this sort of future work if these potential underwater sites are to be located and protected. This sort of large survey project crosses multiple communities, states, and countries' waters So it creates a challenge for how we do this work at this scale in the future. So coming back to the local community, we need to acknowledge that connection to the landscapes, sea country, has deep roots in this part of the world. And these are reflected in very long oral histories. And if you look at the work of Nunna Reid, they argue that some of these oral histories talk about sea level change through the Holocene. So we're looking at really big oral traditions. So part of this project has also been collating these in a virtual story map environment in order to share these and present multiple narratives about the changing nature of this environment. And I think it's interesting to think about this as multiple layers of significant space. So where we're working, obviously the surface is important for seafaring, trade, connectivity, movement, communication. The water column for fishing, economic value, and in natural environment. And the seabed are once active, known human landscape, remembered. I've got my name on the project, but like any big project, it's a cast of many, and I'd like to thank them all because it's taken a lot of people to get where we are so far. We've got a year and a half left. So hopefully, fingers crossed, there'll be more research and data that I'll be able to present in the future. So thank you very much.
Thank you, Helen. Our next speaker is Eric Fisher. And Eric is the senior researcher at the Interdisciplinary Center for Archaeology and Evolution of Human Behavior at the University of Algarve in Portugal. He's had almost 20 years of experience working in the Horn of Africa and does data analysis, archaeoinformatics research, and has recently started the P5 project, which is an international and interdisciplinary collaboration studying hunter-gatherer adaptations to coastal environments in glacial and interglacial phases. So he's going to be talking to us about Africa. Eric?
Good morning. Thank you very much for inviting me to be here at this auspicious event celebrating the University of Michigan's Museum of Anthropological Archaeology. Before I begin, I just want to briefly wish my son Colton, who's watching the live stream back home in Portugal, a very happy 6th birthday, which was yesterday. He's very excited. Happy birthday, bud. All right, let's do this. Around 165,000 years ago, a small group of highly mobile people occupied a small, dark, and narrow cave during a prolonged glacial period. The group wasn't large, an extended family of perhaps less than 20 men, women, and children who moved throughout the landscape collecting seasonal foods and other resources. Some of the group were hunting for terrestrial game, common large ungulates like springbok, wildebeest, or eland. Others were on the coastal plain laid out in front of the site. At that time, the coastline was about 5 kilometers away, a short walk out and back in a day, and it provided ample opportunities to forage for plant foods like tubers and corms, as well as to collect firewood as they made their way to and from the coast where they collected mussels from the exposed low-tide rocky intertidal zone. The mussels that they brought back to the cave were cooked and consumed and dumped along the cave walls alongside discarded stone tools, bones, and nubs of pigment crayons made from red ochre. And it was a regular occurrence for these people who had clearly learned by now how to target the coast when the tides were at their lowest, spring lows, but also to safely exploit intertidal zones between lunar cycles. Unknown to those people, though, was that a few millennia before them, that cave was an inland cave, Located dozens of kilometers from the sea, and a couple millennia after them, that pattern would repeat itself as global sea levels dropped again. And when the coastline left, so too did the people, leaving behind that cave and perhaps to follow the receding coastline as they adapted to the changing landscapes, returning only about 40,000 years later during the last interglacial period when sea levels were higher. Of course, the site that I am referring to is real. Cave PP13B at Pinnacle Point on the south coast of South Africa was excavated by a team led by Curtis Marion in the mid-2000s, and it remains our earliest evidence for systematic coastal foraging in the world. Since the 1960s, excavations at Colossi's river mouth and numerous other sea caves along the South African coast have revealed fascinating insights to when, where, and how early modern humans learned to use coastal aquatic resources. It's clear that the coastlines in each of these places provided a centralized location for hunter-gatherers to move between land and sea and exploit their diverse terrestrial and marine plant and animal foods, often offsetting the risks inherent to each resource. And what these discoveries and numerous others worldwide have helped do is to shift the global perception of aquatic resources from marginal foods desirable only under the direst circumstances to becoming a key component in the story of human evolution and survival during the Pleistocene. For example, John Parkington, Michael Crawford, Lee Broadhurst, Stephen Kanani, and numerous others have hypothesized that an influx of nutrient-rich marine protein aided the cognitive evolution of anatomically modern humans after 300,000 years ago, leading to the behavioral changes and novel innovations characteristic of the modern behavioral repertoire. Meanwhile, Curtis Marion has hypothesized that advanced cognition, like modern working memory, preceded coastal adaptations. Marion also sees important downstream behavioral implications in the transition to a fully coastal adaptation, like how the defense of dense, predictable coastal resources could have led to territoriality, elevated conflict, and the development of prosociality within modern humans. And more broadly, there is even compelling evidence that coastlines and waterways provided key routes for human dispersals out of Africa and around the world during glacial phases of the Pleistocene. But really, how influential were coastlines to Pleistocene hunter-gatherers? The honest truth is that we really don't know, because the records that we have provide only very brief glimpses of coastal foraging, glimpses that are dependent largely upon climatically driven sea levels that influenced the coastlines and their proximity to the archaeological sites that we study today. During the Pleistocene, the Earth underwent repeated changes in climates. During glacial phases, more oceanic water was trapped in polar ice caps. Leading to drops in global sea level, whereas the ice caps melted during the interglacial phases, resulting in higher global sea levels. One of the most substantial periods during the last ice age was the period of maximum ice sheet expansion between 26,500 years ago and 19,000 years ago, known as the last glacial maximum, or LGM, as I'll refer to it here. Sea levels were nearly 125 meters lower than today, leading to widespread exposure of continental shelves worldwide, including Sundaland and Sahul in Southeast Asia, and the Bering Land Bridge connecting Asia to North America. In southern Africa, as much as 80,000 square kilometers of seafloor was exposed across the very broad and flat continental shelf during the LGM. This area was equivalent in size to the island of Ireland. On southern Africa's south coast, structural, climatic, vegetation, faunal, resource, and behavioral models have all been used to generate a paleoscape for the now extinct Paleogolus plain, which, among other things, has been hypothesized to have provided a significant range expansion for grassland habitats and grazing taxa, making it likely very attractive to prehistoric hunter-gatherers. But we cannot say with any certainty if or what people were doing on the Paleogallus Plain, or most other glacial coastlines, because during this time, archaeological records are not only rare overall, but records of coastal foraging cease. Scant evidence for coastal foraging does not reappear until only around 15,000 years ago, and really only appears in abundance 13,000 years ago with the onset of the Holocene and the return of relatively high sea levels. As noted in numerous studies, this pattern is anthropogenic. Ethnographic observations and archaeological records worldwide demonstrate that hunter-gatherers rarely exploited coastal resources when the coast was beyond 5 to 10 kilometers of their home base, roughly the distance out and back that a person can walk in a day. But even after 1 kilometer, these studies show that there are changes in prey selection and field processing that can influence visibility in the archaeological records. And the implication is that hunter-gatherers seeking coastal resources during glacial times had to move out onto exposed continental shelves if they wanted to remain within daily foraging range of the coast. The large gaps we now find in coastal foraging records therefore may be explained by the combination of low glacial sea levels, drawing hunter-gatherers out onto exposed areas, and rising sea levels during interglacials, sweeping across the exposed continental shelves and obliterating traces of glacial human occupations in those low-lying areas. What we are left with today are only short and disconnected interglacial excerpts from a much larger story about people's relationship with the sea. And it means that we lack a clear understanding of the long-term evolutionary development of these behaviors, their long-term implications on human biobehavioral evolution during the Pleistocene, and the ability to effectively test our hypotheses across glacial and interglacial phases. And it's a problem that I have chased for 15 years, and one that many of my colleagues in Southern Africa have chased for far longer. One solution is to study submerged sites directly, but there are numerous complications in Southern Africa. Diving surveys of the now submerged Paleogallus Plain around Pinnacle Point, for example, have used seismic, side-scan sonar, and multi-beam bathymetry to identify a succession of subaerial and submerged paleodune and paleobeach deposits on the shelf dating back 135,000 years. Submerged cliff and cave formations have even been identified. However, so far, no archaeological remains have been observed in any submerged context. The reason is due to the Agulhas Current, one of the fastest in the world. The consistent flow path on the southern African seaboard becomes a chaotic jet of water further south as it interacts with numerous other currents before turning back on itself in the Agulhas retroflexion zone. And these turbulent water conditions simultaneously scour the seafloor and rework sediments on the shelf. It also creates a turbid and low visibility environment that happens to host one of the largest populations of white sharks in the world. So on the one hand, you can't see the very gigantic sharks that you know are swimming around you, but on the other hand, you can't see the archaeology either. The study conditions are less than ideal. I like the metaphor for cold tea. Another option, the one that I have pursued, is to find places on land where missing coastal foraging records may in fact still be preserved. And in 2010, I started an intensive study of the Southern African continental shelf, looking not only at its width, but also at the terrestrial conditions that would promote the preservation of fragile archaeological deposits. One place that stood out immediately was Mpondoland on South Africa's east coast. The continental shelf there is less than 8 kilometers wide and never exceeded daily foraging limits from sites on the modern coast, meaning that prehistoric people on that coastline always had access to the ocean And modern archaeologists today have access to the traces of those people. Today, Pondoland is characterized by tightly packed endemic and ancient vegetation zones, including Afro-temperate and coastal forests, as well as open woodlands that are interspersed with grasslands and wetlands. Each of these vegetation types supports different plant and animal resources. And the warm water Agulhas Current offshore maintains this diverse vegetation through coastal precipitation, and it also sustains intertidal shellfish and littoral fish communities. On land, horizontally bedded quartzitic sandstone cliffs at the coast and along the waterways also promoted the frequent formation of rock shelters that help to preserve fragile archaeological deposits. Our initial survey in 2011 documented over 24 archaeological sites in Pondoland, ranging in age from the early Stone Age to historic European shipwrecks. My attention quickly focused on one particular site at Waterfall Bluff, where our early data suggested occupations dating to the late Pleistocene, perhaps even the last glacial maximum. With sea levels 125 meters lower today, the LGM is on par with the marine isotope stage 6 and MIS9 glacial maxima at 134,000 and 344,000 years ago, respectively, which encompasses the time frame of the modern human lineage. The LGM is also within the limits of radiocarbon dating, making it easier to study relative to earlier time periods. So, finding evidence of coastal foraging dating to the LGM would act as a proof of concept that coastlines were constrained within foraging radii across glacials in Pondoland. And before now, a coastal glacial maximum archaeological record in Africa did not exist. Waterfall Bluff is an 80-meter-long coastal rock shelter located 24 meters above the sea next to the Mlamukulu waterfall. We have excavated at the site since 2015. We use global navigation satellite systems, total station mapping, and photogrammetric models derived from unmanned aerial vehicle surveys of the shelter floor and cliff face to link the site to the surrounding landscape. These models provide a multi-scalar perspective of the landscape surrounding the site through to granular observations of our stratigraphy visible in our high-resolution color-calibrated photomosaics, like what you can see here, showing the stratigraphic walls within the excavations. We also plot all archaeological remains, fauna, stratigraphic surfaces, and samples to millimetric accuracy using our total stations. And our collaboration with South Africa's Itemba Labs has also created one of the most comprehensive radiocarbon chronologies for the late Pleistocene in southern Africa, which complements our single-grain optically stimulated luminescence chronology developed at the University of Wollongong. This chronology documents repeated occupation of the rock shelter from 36,000 years ago during marine isotope stage 3 through the last glacial maximum, the last glacial interglacial transition, the early Holocene, and to around 8,000 years ago during the middle Holocene. Finding evidence of coastal foraging, however, has not been as straightforward. In 2015, we began excavations along the drip line because it had created a natural exposed profile. No shell was found in those excavations, however, but the stratigraphy showed multiple dark bands, which appeared reminiscent of decalcified and compacted deposits. So using mineralogical analysis and scanning electron microscopy, we identified the nacreous remains of Mytilidae shell within sediment samples taken from that area in the drip line, giving us our first hint of coastal foraging during the glacial maximum. And this study, which was led by Annette Ertl and recently published in Journal of Archaeological Science, revealed a seemingly invisible component of the archaeological record. Subsequently, we have stepped our excavations into the rock shelter, and preservation of both stratigraphy and shellfish has increased significantly. We have now documented a robust and diverse use of coastal plant and animal resources from all layers. Evidence of coastal intertidal foraging during the last glacial maximum is dominated by brown mussel, smaller quantities of limpets, and a few Natal rock oysters, all of which are common on rocky shorelines today. In total, there are about 17 different marine invertebrate taxa in the assemblage. The fish taxa are from species common today in estuarine environments. Interestingly, the poor preservation of bones from the branchial region may possibly be due to field processing close to their area of capture. And recently, we have also identified the remains of Cape fur seals from LGM layers. We've also discovered a variety of shaped bone tools throughout the excavated sequence, some with possible fishing applications. Rock art representations of fishing in the Eastern Cape and Free State of South Africa show hunter-gatherers spearfishing and line fishing, sometimes from floats. At Waterfall Bluff, we've recovered a broken bifacial point, seen here center top, that is similar in size and shape to ones reported from Nelson Bay Cave in South Africa. Additionally, we've also recovered a possible broken line fishing gorge there at Wright. The size and shape of the worked bone object is similar to fishing gorges that have also been found at Nelson Bay Cave and Alon's Bay Cave. There are also numerous perforated shell ornaments from deposits dating to the last glacial interglacial transition and early Holocene, including ostrich eggshell beads. Pondoland's paleoenvironments are being studied by our multi-proxy archaeobotanic team, which is leading studies of plant pollen, silicified plant remains like phytoliths, charred wood, preserved plant tissues, plant starches, and leaf wax isotopes. These studies, which have been published recently in Quaternary Science Reviews, show that all major vegetation zones were sustained during marine isotope stage 3 and the LGM. And this finding is corroborated by our offshore mapping, showing incisions in paleo rivers on the submerged continental shelf that indicate freshwater runoff from precipitation during glacial periods that would have supported both people and the vegetation. Iron-potassium ratios from marine sediment cores can also be used as a proxy for riverine runoff, thus wet versus dry conditions. And the marine core 200 kilometers northeast of Mpondoland accords with our results, showing wet conditions during the last glacial maximum and other glacials. Ongoing analysis of our faunal data by Jerome Renard and his student Sandy Oster likewise suggests a sustained grassy and moist paleoenvironment across the Pleistocene-Holocene transition, composed of mostly grazing and mixed feeding taxa with rare exclusive browsing species. These environments would have provided plant resources too, including wood for fires and implements. Suzanne Bota is leading our ethnobotanic wood foraging study in South Africa, and her results demonstrate that the modern environment in Mpondoland is highly resilient to weekly fuel wood collection by numerous people. It's also a task exclusive to women, and there are no age-related differences in harvesting returns. Foraging for intertidal resources is also common during wood foraging trips. Our marine ethnographic research, which is led by Jan de Fenk, has documented modern Amapondo foragers collecting intertidal marine resources, often at or near river mouths and in estuarine environments, not unlike the habitats inferred from our archaeological fish assemblages. Intriguingly, we see parallels between our modern ethnographic observations and the archaeological records. Our charcoal specialist, Alison House, has identified multiple species, charcoal endemic to coastal forests, in our LGM archaeological charcoal sample. Taken together, these data show that people during the LGM targeted estuarine environments like modern Amapondo foragers do today for a variety of resources, shellfish, fish, and wood, and it creates yet another tangible link between the archaeological records at Waterfall Bluff and the coast during the glacial maximum. Our research at Waterfall Bluff provides a window into hunter-gatherer behavior across a glacial-interglacial phase in a persistent coastal context, which has never before been studied in Africa. Our work at Waterfall Bluff demonstrates that records of coastal foraging from glacial maxima do still exist. It provides a new and clear signal that groups of hunter-gatherers occupied the coast throughout the last glacial interglacial transition, that coast supported Afro-temperate forests, grasslands, and bushveld alongside freshwater rivers, creating estuarine environments where marine fish, shellfish, and marine mammal remains, as well as firewood from coastal forests, were exploited. In our 2020 publication in Quaternary Research, we hypothesized that these findings hint at a diverse pattern of coastal exploitation at Waterfall Bluff. Not an exclusive focus on the sea, rather a centralized location between the land and the sea and their plant and animal resources that attracted people amid regional, climatic, and environmental variability. Where do we go from here? Waterfall Bluff validated my original intuition about Impondoland, and now it's time to target our middle Pleistocene sites. Our oldest current site in Impondoland is at Imtikaba, a coastal dune with stratified paleosols. And our OSL ages there, for the first time, show that these East Coast red dune deposits have been dated in the age range from 300,000 to 130,000 years ago. Early Stone Age large cutting tools and cores are found in abundance across the sites, as are Middle Stone Age artifacts, with refitting pieces that we have minimally dated to the marine isotope stage 6 and MIS 5 boundary 130,000 years ago. My plan all along has been to work from both ends of the historical spectrum and build a single continuous record of coastal foraging in southern Africa for the first time. I am now confident this goal is achievable. What makes Imtikaba, Waterfall Bluff, and the numerous other sites like them so exciting is that they preserve deposits that span the time frame for the origins and evolution of the modern human lineage. Within Impondoland, the narrow continental shelf means that these occupations were always in a continuous coastal context. And it sets my team up to begin searching for new evidence, older evidence, about when, where, and how humans learned to rely on the sea so that we can fully understand the long-term implications of those actions on our biological and behavioral evolution. Thank you very much. And if you're interested in learning more about our project, we have numerous social media links and things online. Thank you very much.
Thank you, Eric. I'd really like to think about the west side of that cape where you don't have the same currents. Our next speaker, I'm very pleased to introduce, is Angela Rodriguez, who comes to us from Colombia. She was also trained at the University of Southampton, which makes this weird kind of connection between us and Cambridge and Southampton kind of complete. Angela works on underwater projects at the Columbia Institute of Anthropology and History and is an advisor for underwater cultural heritage and focuses a lot on the creation of new regulations to protect underwater heritage. Angela, is telling us about South America, which to me is the great unknown continent, even more than Africa. And she's fortunate to have worked not only in Colombia, which has both an Atlantic and a Pacific coast, but also in coastal Chile, which again is a very interesting environment. So, Angela, remember your mom.
Good morning, everyone. Thank you very much for coming, and thank you very much, Uma and John, for inviting me. John asked me to think about South America and submerged archaeological records. And really, in South America, there's not much of it. So I'm going to talk a little bit about the differences between each coast and how we can think about the submerged archaeological record depending on where you're sitting at in South America. Basically, the eastern continental shelf in South America has a very low gradient, and it's relatively wide. So it offers a potential for a lot of sites. And during the sea level, the last glacial maximum, I'm sorry, sea levels were very different, as we've heard from Helen and from Eric. And this applies in South America as well. This coast in particular has the potential for a lot of inundated sites. In contrast, the Pacific coast has a relatively narrow width, and it has the high relief of the Andes and the Nazca South American plate subduction zone running parallel to the coast. So in this case, you really need to think about individual bases for in order to look for sites. In the Atlantic, in particular, chance finds have come from the Rio de la Plata basin, and also from near the south side of Brazil. And these are mainly fossils from terrestrial mammals that come from large concentrations of marine and terrestrial skeletal remains. But they are found between the 0 and 20 meters below sea level, and between 20 and 36 kilometers offshore. And also the Rio de la Plata basin, it was a major estuary during the last glacial maximum. And the conditions were basically very good for extensive foraging, and the environment consisted in a highly productive ecosystem, which was used mainly by large herbivores. So it is very likely that the location for earlier human habitations. So those are two potential areas that we could focus on. Unfortunately, there hasn't been many records. It hasn't been worked as much. One of the examples from this coast is the La Olla site in Argentina, a little bit further down than the Rio de la Plata, so further down than Buenos Aires. This site in particular is located in the intertidal zone of the present beach, and is remarkably well preserved. The human occupation at the site was dated between the 7,400 and 6,480 years before present, and it is interpreted as a place for the processing and consumption of the southern fur seal and the sea lion. Basically, a lot of studies have been made in this site, trying to figure out how the environment changed and how it was used. And La Olla exhibits exceptional site integrity with remarkable high-resolution archaeological deposits containing well-preserved organic materials, thus yielding an important assemblage of bone and wooden artifacts employed by Pampean hunter-gatherers. As we've seen, multidisciplinary research is key in this type of sites, and what has been done in this site has provided substantial new data for the early human adaptation of the Southern Atlantic during the early and middle Holocene periods. Now, coming to the Pacific coast in Chile, which is where I worked at, the site, GNL Quintero. Sorry. Here. Sorry. It's the only documented late Pleistocene drowned terrestrial site along the Pacific coast. So, like I said, evidence is very scarce. Only one little tiny site in the whole continent of this really long coastline. And it is important for the reconstruction of past environments in areas where that were used by humans and that are today underwater. So basically, in this part of the country, the bay or the site actually is 650 meters from the coastal line, the current coastal line, and it's between 13 meters of depth in a place that had sea levels at least at 120 meters less than there are today. The site was discovered whilst archaeological work was being done in association with the construction of a natural gas terminal in the Quintero Bay. So, as Helen mentioned, it is very important to work along with the industry and try to, especially in South America where we don't have as much funding, try to get the tools for us to find information, and from them being able to work on different sites and gather as much information as we can. Extensive work, sediment samples, excavation, and recording of the site has been carried out on several campaigns on 2007, 2012, 2014, and it's continuing to evolve. The site consists on largely underserved deposits with a high degree of integrity, as we can see here. On the seabed, which contain a primary stratigraphic record of continental faunal remains and have been systematically excavated both on-site and at a lab. Diver performing targeted photo coverage of individual bone assemblages has been done, so a lot of high resolution recording, basically to minimize the time that we have to spend underwater doing this recording and to analyze the assemblages in situ and being able to do further research on them. A very well-preserved bone assemblage was recovered with a high taxonomic diversity that includes extinct terrestrial megafauna, but also small mammals. So basically giant sloths, Andean horse, deer, vicuñas, which is family from the llamas, coipos, and other rodents. This quadrant on the left shows how the assemblages was distributed. And as you can see, some of them are very well integrated. For instance, the jawbone of deers, they're completely on site and the way they're supposed to be, like taxonomically. Conclusive evidence supporting human activity at the GNL Quintero site is scarce. It's only represented by 2 bone cut marks. This fact locates the site within the ambiguity cases that usually contribute to the debate of the early peopling of South America, but will require further research. Originally, like I mentioned, the site would have been situated several kilometers inland as the paleo shoreline was further out on the continental shelf, close to 90 meters isobath. This hypothesis is consistent with the taxonomically homogeneous composition of the assemblage of vertebrate fossils and the absence of marine resources in record. Now, considering the exceptional preservation of the evidence, research has primarily focused on investigating terrestrial and marine taphonomic agents and developing improved methodologies for contextual data and bone recovery. A new phase of paleolandscape research strategy has begun, including the comprehensive application of remote sensing technologies, geological interpretation of industrial land and offshore coring, isotopic paleoecology reconstruction, and extensive underwater archaeology excavations is currently being conducted. Now, as we mentioned, and as Helen and Eric mentioned as well, there are sites that are the opposite way around, that used to be closer to the coastline and now are actually farther away and are terrestrial sites. And human occupations on broad and this kind of sites, show how human occupations on broad scales were the process that basically people followed where the resources were. And the unique ecology of this region with diverse and abundant marine resources closely correlates with how the Andes in this part of the coast works. Basically, people moved around between the coast and the mountains, foraging and looking for what they needed in order to survive. So in this case, we're talking about Peru, Huaca Prieta, which is roughly in the middle of the coast of Peru. Some coastal archaeological sites of the late Pleistocene period are located on now submerged continental shelves. Recent discoveries on narrow shelves minimally displaced by rising sea levels or on uplifted shorelines along the Pacific coast have documented human maritime occupations between 30,000 and 11,000 years old. These sites were located within 1 to 8 kilometers from the sea and at the time of occupation, and invariably contained the remains of marine fish, shellfish, and birds, as well as stone tools and debitage indicated of unifacial and bifacial technologies. Not only do these discoveries indicate that marine resources were important to the economy of early forages, but the Pacific coastline and coastal plains may also have been used as an initial dispersion route. So in Colombia, there's almost no information at all. There's not, especially regarding maritime and submerged archaeological records. We have the big potential because, as John mentioned, Colombia is very fortunate as far as where it's located in South America, and we have coasts both on the Caribbean or the Atlantic and on the Pacific. But, like I mentioned earlier, the coasts both have very different processes as far as how the sea level affected the coast. So we have to think in different ways depending on where we are. Now, there's a big debate on the colonization of the Americas and the potential role that seaways, rivers, and the coastal margin have played in this process. In particularly in Colombia, we are talking about the Caribbean lowlands. So basically, as you move further inside the country, pretty much we have flat lands. And also the Chocó, which is on the Pacific coast, right underneath Panama, and the Amazon basin further down. The region suffered repeated environmental changes of variable intensity over time, inferred from temperature, moisture, and rainfall fluctuations as indicated by different climate proxies. Such fluctuations may have had the potential to cause significant ecological modifications resulting from climate-dependent chronological changes affecting vegetal and animal communities. To date, like I mentioned, there is no information from key regions in the country, such as the Caribbean lowlands and a coastal corridor that had to be used by early colonizer groups, shown by some ceramic traditions. One of the ideas that has been put out there is that the dispersal movement of people in South America was very dependent on the river basins. And here, not only rivers, but I want to also mention lakes. But as we can see, Colombia in particular has a very wide network of rivers and lakes. So we have to assume they had to be used somehow, either by walking along the shores of the rivers or even navigation. There's no records in Colombia in particular of prehistoric prehistoric vessels, but we're pretty sure from some small golden figurines that there might have been some kind of vessels used. Very simple but effective to move around. So to conclude, there is a need to conduct very diverse and large-scale analysis and models to help us identify potential sites and think about other ways the landscape has changed and how people interacted with the different environments created by global changes occurring in terms of climate, sea levels, and coastal and river basin geomorphology. Within this submerged landscape lies fragmentary yet valuable evidence for the lifestyles of its inhabitants, including the changes resulting from both the encroaching sea and the introduction of new technologies. Once again, the inundated landscape cannot be explored conventionally. Creation of the use of different technologies is a must. And then multidisciplinary work as well. When John asked us to think about how we could integrate the sea and the land, I had worked on the islands or the archipelago of San Andres y Providencia in Colombia, and we had played around a little bit with the idea of the ideal free distribution model, which is basically a model that comes from human ecology behavior analysis, and you use it to think about the nature of interactions between human populations and their environments in order to study what non-social variables can determine or constrain behavior, including social behavior. With this theoretical perspective, there is a model that has been used basically to determine and assess environments on whether these human settlements were established in an orderly adaptive decision-making process that prioritizes areas with greatest qualities. So it was used to analyze how birds settle in islands. So we kind of went a little bit further and figured out, well, islands, small, people might try to look for the same things. But we wanted to figure out, what decisions were made in order to decide where to live. What factors were important in order to decide where to live and if these habitats were actually suitable for living or not. So the IFD model has been used to analyze the human colonization processes on islands because these are contexts that are considered isolated, so have basically a little bit more of control conditions, and where factors of suitability for permanent human settlement can be easily identified. Some of the variables that we took in place are the marine and terrestrial resources, availability of fresh water, ease of maritime access, and source for agriculture. It was our first attempt, and we mainly focused on historical records in order to do this. San Andres y Providencia it's a little archipelago closer to Nicaragua, but technically belongs to Colombia for some very political reasons that are not necessarily important right now. Recent geological studies carried out in the Caribbean Sea suggest that for this region, although insignificant and regular in time compared to what occurred in other sites, relative sea levels of up to minus 25 meters could have existed compared to the current sea level. This geological information would support the thesis that part of the coastal archaeological record of the Colombian Caribbean produced towards the end of the Pleistocene or the early Holocene near the current coast could have been covered by transgressive events of the sea in shallow water areas. In the case of the islands of San Andres and Providencia, the presence of resources that could be found on the coast, especially in the area near the mouth of the rivers and the mangrove areas, suggest that it is possible that pre-Hispanic archaeological sites, not only for the first explorers, but also of sedentary occupations, are today submerged. In particular, this area was colonized by the mosquito groups. And then when we want to evaluate the relationship between this possibility and the early dates associated with the mosquito groups, it is necessary to presume that some of the pre-Hispanic sites are submerged on the islands of San Andres and Providencia. According to Lambeck, since approximately 6,000 years before the present, the relative sea level of the Caribbean has probably not fallen below the isobath of -5 meters. This means that there are submerged pre-Hispanic sites in San Andres and Providencia. If there are, submerged sites, these may be located between the current coast and the marine area with a depth less than or equal to -5 meters, and would probably be represented by shell middens similar to those found in the Mosquito Coast. According to pre-Hispanic records, there are no known pre-Hispanic settlements in San Andres and Providencia. We haven't found archaeological records per se, but it is believed that the archipelago was part of the territory used by the mosquito hunters and fishermen, who maintained temporary ranches in the islands where they gathered turtles, shellfish, and larger fish, as well as different types of woods, with minimal intervention in the landscape. So basically, this makes it a little bit harder to find as well, because they weren't there permanently. Available archaeological data suggests that these mosquito groups were located on the Caribbean coast of what is now Nicaragua territory, and the earliest occupation associated with these groups has been based to a shell midden at the site known as Coconut Beach, and dates to 3,260 BP. And it is suggested that if the mosquito groups visited the islands of San Andres and Providencia, it is possible that they did so at any time from at least 3,000 years before the present. So what we did is we took information on the geomorphology, the slope, rainy days per year, the presence of black crab, which is a very important source for food in the islands, the distance to beach areas, and the presence of aquifer salinities and the basin density, to create a classification of the islands and basically assign a potential for habitat sustainability. In San Andres, some of the things that we found are very important to have into account is the presence of, or the way the first Europeans arrived to the island. There are very few and little records, historical records, archaeological records. Only now we found 2 sites. The idea is that people settled initially on the east side because it was the part of the island that was easiest to protect, but also it presented a better access to fish and other resources. So one of the points that we ended up figuring out is that the defensibility of the port was one of the important variables for people when they settled in this area. In Providencia, in general terms, the southwestern and western coast of the island has a better suitability than the eastern side. The low suitability in the eastern part of the island seems to be related to the slopes found on the sector. The 2 islands are very different, I have to say, because one of them has a coral reef center and the other one is a volcanic island. Providencia has a lot more water and it has a lot more mountains and different resources. San Andres is very plain in particular, and water, fresh water is very scarce. But what we found is that in Providencia, the population basically concentrated, the white population concentrated on the northwest coast, which is the town of New Westminster was settled. But the enslaved African population was introduced around 1633, and some of them managed to escape and take refuge in areas that technically are considered to have a low habitat suitability. So, just to move up further along, the model explains the occupation of the archipelago better together. The occupation of the islands of Providencia and Santa Catalina was always mediated by the existing conflict between the European colonization companies in the Caribbean and the process of enslaving the African population. Providencia was chosen instead of San Andres as the first settlement due to its easy defensibility. As a part of the English effort to establish a sustainable colony in the middle of the Spanish Empire, a large investment of materials, time, and labor was made to defend the island from possible attacks. The introduction of the African population in a condition of slavery intensified the existing inequalities within the island's inhabitants, causing the intermittent occupation as a refuge of the areas with the least available suitability. In that order of ideas, the process of colonial occupation in Providencia did not comply with one of the assumptions of the ideal model of the free distribution, which is that all individuals compete for resources under equal conditions and can move freely and choose ideal areas for them. So, to conclude, basically, one step further that we could take is that together with information related to sea level and coastal change, IFD could be a useful tool to identify potential areas of activity and submerged archaeological sites, and thus integrate information from both land and sea to better understand the history of this island. Thank you.
Thank you, Angela. I think we should go to Providencia and look for some of those sites. The thought of diving in warm rather than cold water is really appealing to me. The final presentation in our session today is by an alum of our program. It's Professor Ashley Lemke, who is an associate professor of anthropology at the University of Texas at Arlington. Like the other speakers, Ashley has experience in multiple parts of the continent. She's worked on submerged sites in the Gulf of Mexico, in the Great Lakes, and is starting a new project on the Atlantic coast. So she's again got the kind of the range of the continent. She's chair of the Advisory Council on Underwater Archaeology. She's a member of the board of the Society of Historic Archaeology and is the associate editor of Historic Archaeology. So she gets around. Ashley?
Okay, hi everyone. It's so nice to be back here in U of M in this intellectual environment. It's really rewarding. And I just have a tinge of PTSD because the last time I was in this building was when I was defending my dissertation in 2016. So it's nice to be back under different circumstances and meeting colleagues from other parts of the world. So when I was here, the museum was in Ruthven, and in kind of the throes of dissertation writing, of trying to do underwater archaeology, I asked myself what Binford would do if he was working in an underwater environment. And that's kind of led me down this path of conducting anthropological archaeology underwater. So this is necessarily distinct from the historical particularism that really dominates the field of nautical or shipwreck archaeology, which are essentially historical problems. And as you've already heard from the speakers before me, this is a very different kind of broad question we're trying to ask about the past. So instead, I've been focused on crafting research designs, not just for my own particular research in a certain region, but thinking more broadly about how we could do anthropology underwater and make it relevant to a broad audience and kind of move beyond this historical particularism of shipwrecks. So submerged prehistoric archaeology, we have this sort of range of problems or issues that we've been wrestling with as a group of scientists. And the very first one, of course, is how to find sites underwater. You've already heard all the speakers in this session talk about how difficult it can be. That image of a great white shark was actually taken by Eric himself. I think that's an important point to make. So there are challenges, of course, in just finding the sites. But also, one of the questions that John asked us to address is how can underwater data be better integrated with what is a more accessible and a longer established archaeological record from land, from terrestrial sites? So a really holistic understanding of the past really relies on both of these things. You can't just look on land and you can't just look underwater. As they've all demonstrated before me, it's really important that we understand that landscapes looked different in the past. And underwater landscapes are really critical. And one reason is just in their own right for the novel data that they preserve. There's phenomenal organic preservation that's provided by these underwater contexts, particularly in the fresh, cold waters of the Great Lakes, which I'll be talking about. So it's not just that they have data at all, it's that it's unique data, it's novel data that we don't have on land that's unmatched from terrestrial sites. So they're critical for that reason, but they're also critical for incorporating into models, the underwater data to be incorporated into models that are generated from terrestrial data by primarily terrestrial archaeologists. So what I mean by that is models that don't consider the entire landscape at the time of prehistoric occupation are incomplete at best. If you're only looking at half the picture, you're only going to understand half the picture. So any testing of the models that we're going to do for some of these big, broad questions we're talking about, like early seafaring or peopling of the New World, or human evolution, the development of human culture, any test of those models that we might have is going to be really insufficient without looking offshore and underwater on those landscapes that would have been part of where people were living. And some of these more cultural historical models, such as the peopling of the Western Hemisphere, already require revision from the incorporation of underwater data. So here I'm thinking specifically of work at Page Latson, which is an underwater sinkhole in Florida. Work done by our colleague Jesse Halligan has demonstrated with a range of really sophisticated geoarchaeological techniques working underwater and a range of radiocarbon dates and OSL dates that the earliest peoples in the Western Hemisphere were here a little bit earlier than we thought, based just on our terrestrial models. So you have to have both. Submerged landscapes and the sites they preserve are critical, both for their data, but also to make sure we're accurately testing our models about the past. So there's these two kind of big problems that we still face as submerged prehistoric archaeologists. And one is, okay, we know we have this novel data, so how do we connect it to those models? How do we connect the submerged and terrestrial records together? And moving beyond that, things that I've been thinking about more recently is kind of beyond our theoretical applications and modeling past lifeways. What I have been faced with really recently is that cultural resource management, particularly in the United States, of submerged landscapes is outpacing the field. So what I mean by that is submerged prehistoric archaeologists working academically are making significant methodological advances. We have new data insights that are gleaned from our research, but it's really out of sync with the current federal guidelines that are also very insufficient and are designed for shipwrecks. And there aren't best practices for how to manage these underwater cultural resources. And the other thing that's really important is there's an extreme lack of expertise in this type of archaeology in the current workforce. So what I'm thinking about specifically is there's a lot of offshore wind farm development happening right now. And I've been working for a CRM company in addition to my other job for the last 9 months because there's no one else to do the work. there aren't enough people in the workforce to manage these resources, even though there's millions of dollars being poured into the offshore wind farm industry right now. So that's problem 2. So thinking about research questions, you have first this novel data to address these big questions. Then you also have this need to manage the resources that's happening very fast before best practices for their discovery and investigation are developed. So these are both how and why questions about the past, but they're also kind of more simple what, where, and when questions about the past. And by necessity, all of these really require the full range of archaeological theory, anywhere from these relatively low-level formation processy theories to higher-level analytical and synthetic modeling. So the underwater world has really offered me an experience to kind of go back and forth along this range of theory and also balance that divide between method and theory to think more broadly about science and heritage, but also kind of move, Binford 1964, consideration of research designs, to 2022 and start thinking about things like accessibility, diversity, inclusion, and working with community partners. So with that, I want to share a little bit about a case study from working in the Great Lakes to example some of these more broader and kind of basically essentially how you're looking at these 2 different problems in underwater archaeology with the Great Lakes case study. So this is funny, it's nice to be back here. I don't have to give too much of a map of the world of where we're at because we're right here at the Great Lakes. There was an extreme fluctuation, so essentially since the last ice age, in all 5 of the Great Lakes basins. There was both high stands when water levels were higher than modern, but there's low stands, which are most of interest to submerged prehistoric archaeologists, that resulted in vast amounts of land that were available for humans and plants and animals to occupy in the Great Lakes region. So it looks something similar to this 9,000 years ago. So the Alpena Amberley Ridge is one of these landforms that is just in the Lake Huron Basin. Between around 11,000 and 8,000 years ago, there were 250,000 hectares of land that would have been available and dry, and this is just in the Lake Huron Basin alone, so just one out of those 5 Great Lakes. The landform now is around 25 to 35 meters below water, and there's a cultural occupation that dates just around 9,000 years ago. And this is the result of study that John and I and a number of colleagues have been working on for the last 10 years. One of the most important things, of course, right, where we're getting this novel data, like many of the session participants have mentioned, is that organic preservation that's so fantastic. So one of the most recent results from the research working on the Alpena Amberley Ridge in Lake Huron is a peat bog. So there's actually 2 of these different peat exposures that are in the lake. One was found last summer and one was found just a few months ago. And this is a section of peat. You can see it being sampled underwater. So it's in about 80 feet of water, and then you have about a 50 centimeter, at least on the one edge of the exposure, peat bog. This is wonderful, of course, because as archaeologists, we know that there are a lot of really great things that are preserved in peat bogs. So to have one of these below water in this really cold, freshwater environment, there's seeds, there's leaves, there's reeds, and we've just started sampling these 2 exposures. And samples from these actually are currently in Madison. They were just transported there about a week ago for environmental DNA and ancient DNA. Most of the work has focused on caribou hunting architecture. So on the Alpena Amberley Ridge, that cultural occupation thus far is really dominated by stone-constructed hunting features. These are things like drive lanes and hunting blinds that serve to channel animals into predictable sites on the landscape. So these types of structures are found all over the world. They are also found in the Arctic on land for targeting caribou. And they're really similar in the sense that they are a common solution to a common problem of how do you hunt migrating animals a little more efficiently? How do you guide them exactly where you want them to go? And hunting blinds, of course, to conceal hunters while they're waiting for the animals to be channeled into these predictable areas. In addition to the sites themselves, there's also been a range of archaeological testing underwater in Lake Huron. This is just an example of some of the debitage that's been found from the hunting architecture sites that are there, including one of the tools. You will get to learn more about these stone tools in Brendan Nash's forthcoming dissertation. He's a current PhD student here at UMA and is working on this project. But one of the more recent findings, although the tools themselves we've had for a while, are these two flakes. So you're just looking at the reverse side of two pieces of obsidian. So obsidian, of course, is wonderful for archaeologists to find, right? Prehistoric peoples really liked it in the past for its really sharp, wonderful cutting abilities. Archaeologists really appreciate it because it's so easy to geochemically source. So these are two stone artifacts that are 100 feet underwater in Lake Huron, and they sourced geochemically to the Wagon Tire obsidian source in Oregon, in eastern Oregon. So it's a distance of over 4,000 kilometers. So again, at the early Holocene, you are seeing different kinds of human behavior. You see built stone structures, you have this really wonderful paleo-environmental context that's preserved underwater, and then you also have, even with a limited assemblage of artifacts, starting to understand these traces across the continent in the early Holocene. So these connections that stretched all the way from eastern Oregon to the Great Lakes 9,000 years ago. Now, hunting architecture is something that this is one way that it's easy to incorporate underwater data into bigger anthropological problems. Building these structures is not something that's unique to the prehistoric peoples in the Lake Huron region. This is something that folks all over the world have done and that I studied in my dissertation and a book that just came out this year. It's a form of literal niche construction. These are an example of built environments where foragers are acting as ecosystem engineers, constructing the environment around them to gain these more predictable resources. But it also relies on traditional ecological knowledge. To build these structures and have them work, although they seem simple, they rely on a really intimate knowledge both of the local environment, but also of animal behavior to know exactly where they should be. They aren't random across the landscape. They're in systematic, strategic places for capturing specific types of animal species. So an offshoot of this underwater research that's been really interesting the last several years is working on a virtual world. So working underwater is challenging, of course. There's a lot of data to process and think about, and also it's just a big space. Even just Lake Huron by itself is a really large area to conduct underwater archaeology in. So working with computer scientists at Wayne State University, we've collaborated and made a virtual world that relies on predictive modeling and also artificial intelligence. There's artificial intelligence caribou that migrate across the Alpena Amberley Ridge in this digital virtual world. And it serves first as a data repository. So every time a new archaeological site is found underwater, we map it into the virtual world. Every time, a peat bog, for instance, is found or a 9,000-year-old rooted tree, it can be added to this virtual world. And there's also a virtual reality component. So anyone can put on an Oculus headset and wander around this landscape as if it were dry land, even though now, of course, it's in 100 feet of water. So it helps us as researchers visualize a landscape that no longer exists. And this is what it looks like. So these are some screenshots from the virtual reality program of the Alpena Amberley Ridge, where it has bodies of water, it has trees. And again, these aren't an idea of what this might have looked like. We have evidence of where the bodies of water would have been. There's 9,000-year-old rooted trees, so we know what's there, and that's how the virtual world gets populated. This is if you were standing on the shores of what wouldn't have been Lake Huron, was actually Lake Stanley at the end of the last ice age. And of course, we're all underwater archaeologists, so you have to be able to scuba dive off of the Alpena Amberley Ridge in virtual reality and get to see what that underwater environment would have looked like. Now, this is something that has taken the next steps to correct. You had this tool that was for research for this data repository, but it became really clear that it could be used for a lot of other things. So working with members of the Western Arctic Caribou Herd Working Group in Alaska, indigenous hunters who have traditional ecological knowledge, they are knowledge holders of caribou hunting, they can enter this virtual world and made comments about what it looked like, if the environment looked like if it was right, if the caribou were moving correctly, if the sites seemed like they were in strategic places to be able to hunt caribou. And it's this really fascinating kind of interdisciplinary dialogue between computer scientists and artificial intelligence caribou and traditional ecological knowledge holders entering this landscape that's 9,000 years old. It's collaborative, and that's a really important part of this. So we're working hand in hand with the native village of Kotzebue to improve this virtual world as it gets further developed. Eventually, it's going to be able to be placed in other environments around the world. So it started on the Alpena Amberley Ridge, but it can be used to map submerged landscapes in other parts of the world as well. And it can present indigenous views about the landscape, about traditional ecological knowledge, and of course, highlight how important that intimate familiarity is with the environment and hunting these animals on a day-to-day basis for subsistence, and incorporate all that into a virtual world. Eventually, it's going to be embedded with oral histories. This is something that has been really interesting for us to think about because as you wear the headset, you have a microphone and it can record everything you're seeing. So one of the things that collaborators in the native village of Kotzebue had said, one of the elders, was that he really wanted to teach his grandson and granddaughter how to caribou hunt. But the kids just wanted to play video games, like they didn't want to go outside. We were like, what if we made the caribou hunting a video game? And then you could all do it together. So one of the things that's been really fantastic about this virtual world is that it's going to allow for these intergenerational experiences. So more than one person will be able to be in the virtual world at the same time. They can have their grandparent explain, what they're seeing and how to hunt, and that can all be recorded for oral history purposes. And also just get everybody, again, to experience these completely forgotten worlds that are underwater. One of the biggest challenges we have as underwater archaeologists is that the sites aren't really in public consciousness. They're invisible, you can't see them. Most people aren't scuba diving, they're certainly not scuba diving 50 miles offshore in 100 feet of water in the Great Lakes. So this is a way to make this work more accessible by just having an Oculus headset. So you don't have to, get in a scuba tank and jump in the water. So what are some lessons from this particular case study? First, models built using just terrestrial data from the region wouldn't have explained and do not explain what we found below Lake Huron. If we were working on the assumptions we had from terrestrial archaeology, we should have been finding big lanceolate fluted points, and that's not the case. We definitely didn't think we were going to be finding hunting structures. Nobody had that idea that these early occupants of the region were using these built environments and creating these tensions of storage and labor and collaboration and all these different things. So if we would have just gone in with the expectations that we had from the terrestrial models, it didn't work. It didn't explain what we found. And kind of related to that, one of the things that has been interesting doing this work is there was no extensive culture history of other archaeologists working in the region, right? You couldn't go and read what other people had done because we're the first people to do underwater archaeology of submerged landscapes in the Great Lakes. So again, there weren't those expectations from prior research about what the sites have looked like. So what that tells us is just highlighting that point from the beginning, that models that don't think about the underwater landscape are incomplete, and they need the incorporation of submerged data. And they're also providing new answers to what, where, and when questions about the past. And to get to those bigger questions, how does submerged data start talking and interacting with anthropologists that are interested in broader questions? This is an artist from Germany, let me use this. This is a reconstruction of a Mesolithic campsite. And I think you can see the tidal wave that's coming in here in the background. This is showing humans responding to climate change and rising water levels, right? This is something that we're all really familiar with in our particular place in time. And this is something that prehistoric peoples had to encounter and did encounter a lot in the Great Lakes, but also in all these other parts of the world that the other presenters have discussed. So human responses to climate change, foragers building permanent landscape structures, all of these different broader questions we ask as anthropologists, right? Early human evolution, early seafaring, all of that relies on underwater data, and it's just up to us to go in and collect it, and then also always keep in mind that we're anthropologists doing it. So finally, some of the contributions of this work, of course, is providing a better understanding of indigenous populations at the end of the last ice age and into the early Holocene. There's always this focus on making sure that, this is like what would Binford do? Making sure that there's anthropologically relevant research that's being conducted, but also as being a professor, one of the important things that I really see, particularly knowing that there's so much of this work with wind farms taking place and millions of dollars being poured into these new sustainable industries, that none of my shipwreck colleagues know how to do this. So I brought students from Texas here 2 years ago to come to the Great Lakes. They were very cold. They were very overwhelmed, but they learned how to do submerged archaeology. So not everyone is going to be a prehistoric underwater archaeologist, and that's great. But one of the things that we need to do is think about training this next generation of people who are at least aware of the possibilities so they can help out their cultural resource management colleagues and the sense of protecting both intangible and intangible underwater cultural heritage. So with that, I'd like to thank you very much. And I think we're going to do questions over here. Happy to stay here.
Thank you, Ashley. As everyone heads for the coffee room, if there are any questions, I think we can entertain them now, and we'll be happy to do so. Anybody have any questions? Yeah, David.
I want to comment on Ashley's paper. Oh, I'm sorry. I'd like to comment on Ashley's paper. As somebody who was engaged with the National Landmarks Program to put together a story about the earliest Americans 20 years ago, we didn't have any of this information. And as somebody who's done a lot of work with cultural resources in the federal government, you're correct. There is no systematic approach to looking at these sites in terms of federal regulations. How do you suggest that be done?
It's a challenge for sure. Yeah, I was headhunted by a cultural resource management firm on accident. I didn't realize it was happening. And I think one of the most important things that I learned from that experience is that I need to break down what I'm finding in my research and create these research designs and those best practices and give them in a really straightforward way to my cultural resource management colleagues because they don't have time. It's happening so fast. That they're not going to read through all these, they don't have the ability to go to conferences, they're not seeing it. So the organization that I currently run, the Advisory Council on Underwater Archaeology, is working on a white paper for exactly this, like the best practices for finding submerged landscapes and then the underwater sites that they protect. And you can see it's a challenging thing and we're kind of all still in the middle of trying to figure it out. But what that working on the offshore wind farms has showed me is that we really got to start helping people. I hope that answers your question. I hope that answers your question.
Is your Underwater Archaeology Council articulated with Secretary of the Interior?
Yeah, vaguely. So the Underwater Archaeology Council is academics and practitioners and folks that work for the federal government. So, and it's a kind of an arm of the Society of Historical Archaeology that does have a good, strong political voice.
Henry.
I have a question for Eric. I'll just chat. It's a minor question of what you're doing. I noticed in the southeast of your existing subterrestrial site, the beautiful waterfall, archaeological site on the cliff to one side, there's another landform undersea that appears to be a similar geomorphic thing with a waterfall and cliffs on either side of it. Have you a plan to go and take a look at that, or have you already taken a look at it with a rover or something like that?
Yeah, you mean just offshore. It's actually, it's fascinating. In that very narrow, like I said, it's 8 kilometers wide. It's a very narrow continental shelf, but it is just packed with so much information. And yes, one of our co-PIs on the project, Haley Cothra, she's in charge of marine geoscience for the South Africa Council for Geoscience. She does intend to try and dive, and we have planned more offshore studies in that area. But it's also challenging because it's such a remote area. It takes us 2 days just to drive out there, and in some places, in order to walk what would be a half an hour walk, you have to drive 8+ hours. As for a ship, you have to, for any kind of drilling or diving or whatever, you have to charter these very large oceanographic ships that can stay out there for multiple days because the nearest port is either up in Durban or Cape Town, East London, something like that. So you just can't park a boat, and then zip out and the sea conditions. It's known as the wild coast for a region. That's because it just decimates ships, and it's been doing that for a very, very long time. But just offshore, I mean, it's fascinating. We see these incisions in the paleo rivers, which are now one of the major habitats for the coelacanth, by the way. So a lot of coelacanth researchers out there. We see these ancient estuaries, and there's so many different geomorphic features out there that we think that actually when that continental shelf was just slightly exposed, it actually made passage across that landscape a lot easier until you get down to another set of cliffs that are currently underwater, and that there may be caves there, but we just don't know. Thank you.
Okay, this question is for both Angela and Helen. What kind of comments have you gotten back from the industries that you've worked with with what you found? Like, have you given this presentation to them, and how have they responded?
So in Australia, they've actually done a really fabulous job of bringing together the industry data sets through Geoscience Australia. And in fact, we're going to have a complete continental shelf mapped with bathymetry and 3D data very soon. So that's something they've put a lot of time and money and investment in. Personally, what reaction have I had? Very little. I think one of the challenges has been that these are really big corporations, and we seem to communicate at odds. So the challenges are, and it's thinking about offshore developments, going back to think about legislation to protect these landscapes. We want to understand the landscapes for scientific reasons and for archaeological reasons, in my point of view, and to protect areas that have potential preservation in the long run, which isn't necessarily what their goals and aims are. And I think, obviously, many companies have done a lot of data sharing, and that's great, but they just don't have the time, the resources, other than giving raw data files. That's about as close as we've got at the moment. I have been at conferences where we have had stakeholders from industry, from commercial offshore, coming to talk to archaeologists, but it's always been very much of a professional, commercial presentation about how we're going to work together, and then they leave before we present our results. So that seems to be the way the communications have been going. It's a little imbalanced. But I think that is changing. I hope that's changing. And certainly with the Australian shelf, it seems to be changing because of the fantastic work that Geoscience Australia have been doing.
Well, Chile and Colombia work very differently. And the work that I did in Chile, I actually worked for a company that did contractual archaeology on underwater archaeology only. So that's very different from the case in Colombia. In Chile, they were very lucky as well that these amazing sites were found on the context of like the gas harbor and then the regular harbor in Valparaiso, which they have a lot of money to actually put into it. And basically, Diego Carabias, who runs the company over there, he convinced these big companies to give him money to do some more research, telling them, well, you know, it will look good for you if we make this. And it took a while, but they came into it, and that's how everything has been financed. In Colombia, as John mentioned, I'm working more on regulations because we're a little bit farther behind in the sense that only now people are starting to think about underwater archaeology and submerged cultural heritage. away from the idea of the big galleons and the gold. And we're trying to convince people and the companies that there's more than just that. So yes, galleons are important, but there is a lot more to be done, and there is a lot more to be protected. So to start, we have to think about regulations and actually telling people, like Ashley was mentioning, how to do the work. And then from them trying to convince the companies that it's actually important, because they're used to like getting their way and we're just gonna do this, so it doesn't really matter. It's a little site. But now when they're faced with, okay, we might get fines and we might get, bad rep from this, we have to actually work with archaeologists. They don't like it that much, but we're here to stay and they have to listen to us. So we're trying, at least now they're doing the work. We haven't been faced with the opportunity as we did in Chile, that we find a site and we can actually work together and try to find and do more research. But hopefully one day we will. So.
If I can add to that, we have a big issue like that in Michigan right now with line 5, which is this underground tunnel and cable and oil thing that Enbridge wants to put through the Straits of Mackinac. And there is no trust at all between this corporate sponsor and even the people that are doing the archaeology in advance of this are basically distrusted because of the source of the money. So, and this is a case where you're dealing with an area that would have been the river that would have linked the Lake Michigan and Lake Huron Basin 10,000 years ago. So it's almost certainly going to have these same kinds of really important hunting sites. And so the question there is, because there isn't good developed underwater standards, that, so everybody is having to hire their own archaeologists to critically evaluate everybody else's archaeology to see what's actually going to happen. And yet the stakes here are multi-million-dollar. And you always worry when there's that much money involved in these things.
Thank you for your talks. I guess I have a follow-up question to that, and that is, marine conservation issues are already very difficult for general publics because you don't see it and you don't experience it on a daily basis necessarily. So my question is, to what extent, what kinds of opportunities or challenges do you see in your various areas for getting the general public behind understanding the importance of submerged landscapes that they have never experienced, may never see, and may not care about? And I understand, I think the VR thing is really cool in that regard, but I'm interested in your thoughts on that issue.
That's a really, really important question because with maritime archaeology, generally, there's a slight out of sight, out of mind mentality. It gets forgotten, it doesn't get funded, it's not seen. So it's really important. One of the things that we need to do is bring it to the fore, to keep discussing it, to keep showing it. But often, submerged landscape research is quite difficult to engage the public, because you don't necessarily have something really quickly, easily identifiable on the seabed, like a shipwreck. So it's about the stories that we can tell with it and how we engage it. I think we've all been trying to do things with virtual reality, with video footage, with things like I did something with TED Ed, an animation, just for children principally. But to try and demonstrate what it is, to get that understanding of this continual landscape and the sea level change, and actually tying it into these questions about sea level change and coastal activity that are so on the fore at the moment, seems to be one way to really engage that and hook that story in. So that's quite a good way of doing it.
I also think it depends a lot on the relationship the communities have with their environment. For instance, in San Andres and Providencia, the Raizal communities, they're very proud of their origins in the island. They came as slaves, but they formed their communities there. So they're very engaged in wanting to preserve the knowledge that comes from the island. Some of the issues we've had, for instance, 2 years ago, there was a hurricane, kind of like the one just came by to Florida, and basically wiped out most of the records that we had in Providencia. It wiped out a lot, but then on the other side, it actually revealed a lot of materials as well. So there was also the opportunity to actually recover new materials and do new research. But at the same time, you're also faced with the idea, okay, so now we have these materials, we want to leave them here so people can actually learn about them and engage with them. But what if another hurricane comes in the future? So they don't have the logistics and the places to actually keep the material as well. So there's a lot of different things that have to be done in order to involve the community and guarantee in the future that they're going to be able to preserve whatever it is that we find. So there's two different issues.
I have a very short story for you. For Ashley Don. So, thank you. So there was this village in the subarctic that have been hunting caribou since time immemorial, and there was 1 year when the caribou didn't come. So they searched everywhere, all their intercepts, all their lines, and they couldn't figure out what had happened. So eventually, it turns out that a shaman from an enemy village had come and put bad medicine in every rock of the drive line to deviate the caribou toward his village. So the hunters that had lost the caribou sent notice to the whole subarctic because they had to find the right shaman that had the power to remove the bad medicine. And when they found that shaman, the caribou returned. So that is a kind of story that really adds a layer of, I don't know, morality and richness to niche construction and ecological knowledge, I think. Anyways.
Let me add a story back to you.
Okay.
When we first started working up at Kotzebue, we took a slide presentation of the different kinds of underwater features that we had identified. And the very first question we were asked, it turned out to be by the village chairman, was, is that what those things are? I have those on my hunting land, and I never knew what they were. And the reason that was so informative to us is because the location of that hunting structure coincided with a much larger population of caribou that existed prehistorically. So the caribou now, you read in a hungry country, people are wandering around looking for an animal. And the models that some people have done, even Sarah here, who's working with us from Wayne State, suggests that there may have been as many caribou going across the Alpena-Amberley Ridge as currently exist in the Western Arctic herd, which is about 200,000 animals. So what was interesting is you have, on the one hand, a real hunter who's been doing this his whole life, living on the landscape, who recognized the things but didn't know what they were because the conditions had changed so much over the 200 years. So it's a very rich, it's a really fun kind of research to do.
And, you know, caribou, because it moved so far, you know, they had like huge information networks across caribou land. And it grows cut, not just villages, and it grows cut linguistic groups.
Yes.
And they would pass information really fast for the season between, say, Lake Athabasca all the way to Georgia Bay.
Yeah.
You know, and so it's not surprising to find from the exotic artifacts as well as, you know, original information informing all of these things. Thank you. Thank you. It was so interesting.
I have a question for Ashley and John too. I was just curious about the obsidian and whether you've thought about how it got from point A to point B.
Yes. Yeah, thanks, Mike. So yes, we've thought about how it got from point A to point B. In the article, it's essentially like we think it's pretty unlikely that an individual person, right, made this whole trip 4,000 kilometers. As anthropologists, we know that words like trade and exchange come with a lot of baggage. So we've been careful to avoid that in particular. But yeah, I think it's basically, it's speaking to a social connected network across that landscape. The ostrich eggshell beads actually remind me a lot like this work that Eric's done and Brian Stewart here of kind of those foraging networks, right, that go these really long distances, which makes good sense. I think the logical next step and what a lot of people have asked me about is if there's wagon tire obsidian in between. So there's wagon tire in Oregon, and then there's the wagon tire flakes in Lake Huron, and if there's any incidences of it. And there isn't, as far as the reading that we've currently done has gone. Wagon tire is kind of a smaller source of these really, what are a lot of obsidian sources in Eastern Oregon. But I think, actually, like Neva's just said, that I think it speaks to probably those information networks and those social networks that as archaeologists, we tend to just glean out from these exotic materials.
But what is interesting is in this time period, people normally think of north-south movement of people, right? The gradual recolonization of a landscape as the glaciers retreat. And what this connection suggests to us is that there was an east-west axis that related to that newly deglaciated landform, which was actually probably a very, very rich ecological setting for these hunters. And that may have promoted this kind of east-west connectedness. And in fact, in British Columbia, they've now started finding sites that have the same kind of microlith industry that we have with the microcores along with large bifaces. So again, in the same ecological zone on that corridor between Oregon and recently deglaciated landforms. And I think that's where this research is going to take us.
Thank you. So this one's for Ashley. Has the Michigan State Archaeologists been treating the underwater sites equivalently to a terrestrial site, meaning like a size or shape, or do you have one site for the whole ridge? And then the second part of the question, what about the other archaeologists for like Wisconsin and Minnesota and Ontario? Do they do the same thing with underwater sites?
I think the first part of your question is, so there's more than one site on the Alpena Emberley Ridge, which is important. So they've got trinomials now, actually a handful of them. We've been working in 3 different areas. So about 10 miles offshore, 20 miles offshore, and 50 miles offshore. And there's multiple archaeological sites within each one of those areas. We ran into what counts as a site, is one structure a site, is a lithic scatter a site? How do you draw those boundaries? And I've effectively just done it the way that terrestrial archaeologists do it. So we have multiple sites in different research areas. As the second part, are you asking how archaeologists, if there's archaeologists working underwater from other institutions? Is that what you asked?
That's how the Michigan folks do it. What about like Wisconsin, Illinois, or Ontario? Do you count it the same way, or are they equivalent terrestrial underwater?
I would like to hope so. I would like to hope so. Yeah, that they would think about them as equivalent sites. There was a lot of skepticism about this work when it first started, and I think rightly so, because again, there wasn't a long history of archaeologists working underwater in the Great Lakes. No one had done it before for submerged prehistoric work. But I think particularly with the obsidian and the radiocarbon dates and everything else, it's clearly a preserved landscape that has cultural features there. So I think it's starting to get adapted into models in the region. It's starting to be cited by archaeologists that are working in these other states that I think are important. And I'm actually going to Canada in the summer to Ontario and then up around by Lake Superior to start working and seeing if they have similar types of sites in their regions as well.
So to add to that, originally the state of Michigan listed them as trinomial numbers, but like UH for under Huron or under Erie or this or that. And the big switch in Michigan was when they stopped giving them these underwater numbers, which were primarily designed for shipwrecks, to real terrestrial trinomial numbers. And that happened about, what, maybe 10 years ago. Well, thank you all for coming. The coffee's still hot, and thank you guys.